Hey, let's roll. I'm happy to be here today. Obviously, I'm going to be the first, so I'll be trying to warm you up a little, remind you that the workday is over, and we have a chance to relax a little bit and spend some quality time. I'm going to talk about HTTP in Ruby and how interesting it all is or is not. Let us start with simple things. My name is Andrey Deryabin. I'm working as a team leader for Evil Martians. To be more exact, I work at the St. Petersburg branch of Evil Martians. There are quite a few of us. Not so many right here, but there are many of us in the city. We have front-end, back-end developers, and even one manager. You might know us as those who love open source. You can see here several logos of the projects we've worked on, and there are more. I'm pretty sure that you have used one of such products or are using one. If some of them are unfamiliar to you, I'll gladly tell you about each of these projects. They are pretty cool. I've placed the front end on the top, and below are the back-end products. Moving on. Apart from open source, we are engaged in commercial development. These are the projects I've been working on recently. That's where the curtain raiser is over, and usually here comes a slide with Gagarin and the word Поехали, but since we are in St. Petersburg, I thought that Peter the Great would be more appropriate, and delays have dangerous ends. Let's roll. I think there is no need to explain what HTTP is. You know all about it. The abbreviation is familiar to you. If not, you can refer to a course by Kirill Makevnin, which is called Working with HTTP. A couple of words about the history, just to refresh your memory. First of all, there are two major dates for HTTP protocol. They are 1999, when version 1.1 was out, which we are still using for Ruby, Rails, because we are Rubyists and Railers. And the second version was out in 2015, and we are happy about it, of course. Let's talk a little about HTTP 1.1. Let's remember that it's a popular protocol, it's stateless, and the easiest way to write is request response. What we expect someday from HTTP 2 is that it's a binary protocol, it has multiplexing, header compression, streaming, and it's management, and many other things. I'm sure you know more than I do, but that's not the point. Let's remember how an HTTP request and response look like. A method request is sent, the very resource where the protocol version is sent. We send some headers. If we have not a GET request, but a POST or PUT request, we also have the request body. And we get similar things in response. Well, but we are not talking about HTTP, we are talking about Ruby. And since it's a meetup, it entails a sort of discussion. I have a question to you. How many Ruby HTTP clients do you know? How many? Probably 3? 6? No, guys, that's too modest. There are 13 here. And these are the most popular ones, which more or less get updates, and there are 5 more, almost completely forgotten, thank God. If we consider them just through README, they appear to be almost identical. You open and see that they are very similar. All of them support all kinds of requests, follow redirect, proxying, authentication. What else can there be? Compression. Not all of them support proxy. Keep alive. Keep alive is supported in all of them. I've checked. It wasn't so quite a while ago, but now it's true. And so on. But that's still not the point. They are all the same, but different. Just like cars. Outside they have a body, 4 wheels, a steering wheel, pedals. But what is different? They all have a different engine under the hood, which makes them operable. And there are only 3 of them. So it's very easy to categorize all the clients. There's a standard HTTP library and 2 C libraries, which have cool wrappers. What else is different? It's DSL, of course. The simple example given when studying Ruby with HTTP, we make a GET request, and it takes 7 lines to make a simple GET request. I think it's too many lines. That's why different kinds of wrappers appear, such as HTTP party, REST client, HTTP RB, and others. What else is different? It brings us to the coolest part I would like to discuss. Because I can't say if those are features or bugs, so let's figure it out. A simple example, actually from documentation. We make a simple POST request to a certain address. The response comes from a simple Sinatra app. Unfortunately, not Hanami. I didn't manage to set up a Hanami application, but with Sinatra it was okay. And as a response, I return status 201, certain headers, and the created body. The question is, what am I going to get in the connection header in the response? What do you think? I pass Barca connection. What am I going to get using the standard NAT HTTP? Any options? Come on. That's a tricky one, naturally. Don't try to run it and check. That would be cheating. Anyone? The response will be Barca, won't it? And that's it. Let's take a look at what we get as the result. Here it is. To me, it was really unexpected. They didn't simply ignore Barca, didn't overwrite it, but simply connection close, and that's it. The question was also about being attentive. I pass an uppercased connection, and in the response I get it downcased. Would you expect that in processing? I wouldn't. Well, but someone picky would say, well, Andrey, that doesn't really make a difference. If we open the documentation, we'll see that it doesn't matter at all. I'd say it doesn't, but it's no fun. The next case is the next client, HTTP client. A correct HTTP request should contain a certain timeout. A timeout for reading, for writing. There should be certain timeouts, and I'll get back to it later. These timeouts are not mentioned anywhere. They are just there, someone had them written and forgot about it, and they aren't covered in the documentation. 2 minutes for sending a request is quite a while. The next request is a simple GET request by a simple URL, and I don't pass any headers here intentionally. But I'm gonna get them back. Which ones? What do you think? No, no. No. Typheus will interfere, but in a very curious way. The question is which ones? That's a right guess. But if we open the documentation, we'll see... Well, we won't see anything. There's not a word about it. But there are always sources. You're right. Since I'm an old man, I can remember dial-up connection, and we were reading articles telling to minimize HTTP requests. In a simple GET request, a header with the name of user agent will be the longest. Those were other people's stories. They are interesting, but personal fail stories are much more interesting. Fail story number 1. When I was young, I was making Groupon. It's a fail story in itself. Well, not really. In fact, it's a good story. And one evening, I was popping beers somewhere in Moscow, and we ended up with this. It's a screenshot of an American website, but we came across a similar thing. I rushed home because when a response from client is too long means trouble. We got tons of alerts received by New Relic. We started figuring out what was wrong, opened New Relic, and it turned out that the problem was at the front end. That is, that the backend operated well. There wasn't anything wrong with the database. There was something wrong at the front. I have simplified it a little bit because there were helpers, and that's how it looked like. What it was all about is that we needed to determine the city by IP address to show an app active for this city, not to show, say, Moscow, and that's how it worked. I was young, I read little source code at the time, I thought that it was going to work well. But I couldn't be more wrong. When I opened the source code of this jam, it still looks just like that. You can check out by the link. And the person who is a guru in teaching, Makevnin, still writes such code. It's awesome and great because it is written just the way the Ruby guidelines teach us to, but there is one major error in this request. What's the error? There are no timeouts. Probably I wasn't the one drinking beer that day. The IPGeo-based.ru developers were also drinking beer and stopped the server, and I wasn't receiving anything at all. It just froze. No response. Conclusion 1, use timeouts. Fail story number 2 is a recent one. I called it a useless box. Just because at a certain point I opened Sidekick and I saw loads of this mess that couldn't process and was failing with an error. Looking at the code, I could see that it wasn't our work, it was an external team engaged with recommender system. I wrote to the guys, look, there is an error here, and I could look into it, but it would be quicker if you help me and explain how it all works. And they responded me with the following questions. What is it? We are making a recommendation system and not digging in the code. What is it? And I immediately sat down with a face like that. I couldn't understand why me, as a developer, cannot figure out what is going on in this request. And it really made me sad. But it can't be helped. We have to control HTTP traffic. As I said, I'm an old man. I know how to use TCP dump. When I don't want to use it, I sometimes use Charles. By the way, Charles helped us a lot when adjusting communication between mobile and desktop apps when we were working on Get. And it was all fine until I realized that it's not developer-friendly. I have to disable something, search, filter, and I thought that it would be cool to create something that would meet the following requirements. Log all requests which I want to be logged, so that I could analyze them to understand what's under the hood, what's going on. Because the majority of things with adapters I've shown to you were made with the help of an instrument I want to tell you about. It's the Sniffer jam, and it's a very good question. I'll get to it later. A question from Twitter, a very good one. It was me who posted it. Awesome. We support a variety of clients. I really enjoy when something works with the box, but I want to control it so it's disabled by default, very easy to enable, and even easier to configure. But we've gathered here not to look into the code, rather to play, so let's play a little.
We'll enable the sniffer and look where the requests are sent when we launch Elasticsearch and search for St. Petersburg Ruby, for example. In the log, we can see that it makes the following requests and uses Faraday, even though it's optional here. And we can see what requests are sent and where they are sent. And it's a more pleasant one here, and you can see that the requests are processed very fast. Apart from logging, we may analyze the request. We can view its headers, the method, and do the same with the response. Log management. Log management is necessary when you have large services and you need to know what goes where. It's very useful when understanding some narrow places where more requests or fewer requests are sent, and detect network problems. For example, we may try to connect PaperTrail the following way, and we'll see the request in PaperTrail. It's less graceful. The log entries, for instance, does all the same, but just changing the logger to a logger which creates log entries, and that's what we get as the result. I find it very pretty. Now I would like to make some conclusions. First of all, read the source code. It's very useful, as I've made certain several times. Write open source, that is awesome. And use Sniffer. That's basically it. Here is my contact information. Getting back to the question about HTTP log. Naturally, HTTP log has a right to exist. But it has several issues. Problem number one, it's poorly written. It uses monkey patching and rewriting methods. I don't like it. Problem number two, poor tests. They check that there is a certain output log, but they don't test what's inside this log. Thirdly, they don't support all adapters. What else was there? Well, it only logs. It doesn't allow you to work with requests as with objects. It produces human readable for you, but where you put it through next, like JSON, you can't do that. In this case, it was easier to make a separate story. From the outside, it seems to be almost the same, but it's all about details.